So in today's video, we're going to be solving this problem right here. It's asking us to find all triples of positive integers where a is less than b is less than c, when 1 over a plus 1 over b plus 1 over c equals to 1 holds. So let's get right to the solution. So let's rewrite our problem really quickly. We have 1 over a plus 1 over b plus 1 over c, and this has to equal to 1. We also have some restrictions that are given, which is a is less than b is less than c. Now at first the solution might seem like it's infinitely many, but it's not. So we're given this right here. Using that, we can create another relationship between the three with the fractions. 1 over a is greater than 1 over b is greater than 1 over c. As you can see, it's the reverse of the reciprocals. This is because, let's just try out a number to show. 1 over 8 is certainly greater than 1 over 10. The smaller the denominator is, the larger the fraction will be. So that's why this relationship is true. So now that we have that, we can use this to solve our problem. Let's use some logic and reasoning with 1 over a really quick. Of course, 1 over a cannot be 1 because it has to add up to 1. If a was 1, that would certainly add up to greater than 1. So a cannot be 1. What else can a not be? A cannot be equal to 3. And now the reason for this is, let's see, if a was 3, then we would have 1 over 3, and since b has to be greater than a, we would have something like 1 over 4 plus 1 over 5. Really, it can be any denominator that's greater than 3. But this is just an example, and that will never add up to 1. That will always be something less than 1. Again, because b and c have to be greater than a. So that if a cannot be 1, and a cannot be greater than or equal to 3, the only thing left for a to be is 2. So a is equal to 2. Now that we have that, we can just write that in on the top, 1 over 2. Now we can just subtract 1/2 from both sides, and we'll get 1 over b plus 1 over c equals to 1/2. Now we're just solving this. Let's do the same thing with 1 over b. Let's apply some logic and reasoning again. Since a was 2, like we saw above, then b has to be greater, so it has to be greater than 2. What else can b not be? Well, let's say if b was 4. If b was 4, we would have 1 over 4 plus 1 over c equals to 1/2, and c has to be greater. So c would have to be something like 5 or 6 or anything higher. And as you can see, similar to what we just did earlier with 1 over a, that will never add up to 1/2 because that fraction will just keep getting smaller. 1 over 7, that's smaller. So therefore, b cannot be 2, it has to be greater than 2, but it also has to be less than 4, so b is 3 by process of elimination. So now that we have 2, we can just write that at the top, 1/2 plus 1/3, and now the problem is pretty much solved there. We can just solve for c by doing some basic algebra. 1/2 plus 1/3 plus 1 over c is equal to 1. That is 5/6 plus 1 over c is equal to 1. Subtract 5/6 on both sides, 1 over c is equal to 1/6. So therefore, c is equal to 6. That is cut off, but c is equal to 6. Now if we write it as an ordered triple, a, b, c, we would have 2, 3, 6. And that is our solution. So at first glance, it might seem, again, that there are infinitely many solutions, but with some logic and reasoning, we can see that there is indeed one solution. Thank you for watching. Please like, share, and subscribe.